today I'm here to talk about 64-bit Windows 7 and really to try to answer the question of, well, when should you deploy the 64-bit version, and also why should you deploy it? And then based on that, well, what are the types of things that you're going to run into along the way if you try to go that direction? So first of all, let's try to see if we can tackle the why question. Why do you want to run Windows 7 x64? Generally, it's just to allow you to leverage the latest hardware capabilities, and then that kind of flows into the software side as well. So from a hardware perspective, one of the main limitations with an x86 operating system today is that it can't go above 4 gig of RAM. And more realistically, it's not even that much. We'll talk more about what that really means and why you can't even get 4 gig of RAM out of a 32-bit OS. There's also a requirement to move to Windows 7 x64 to get support for UEFI. We'll talk more about that as well to explain, well, why do you even want to use UEFI, and then how that plays into the deployment picture as well. On the software side then, most of this then is about being able to have software that could leverage additional memory or leverage additional hardware capabilities. So the software kind of in the past has been the main driver for getting to Windows 64-bit. Now that the hardware is finally catching up and where you're starting to see people buy machines with 4 gig or more of RAM, it's really starting to be the other way around. That initially you say, well, let's move to Windows 7 x64, and then later maybe we'll come across some software that we want to install that would leverage that. Initially, probably not. You'll still probably run mostly 60 or 32-bit applications on a 64-bit OS. So let's dive more into memory and talk about the configuration there. How many of you have a machine today that has 4 gig of RAM or more? Most of you in the room. How many of you are running x64 OS already? Not quite as many, but still a good number. Pretty soon you're going to start seeing that 4 gigabyte configuration be fairly standard in an enterprise environment. Today that's probably not the case. How many of you routinely buy machines with 4 gig of RAM? Much smaller numbers. As that number continues to grow, which it will over the coming months and years, then you really need to look at 64-bit because the OS, the 32-bit OS, just does not support more than 4 gig of RAM. And because of some oddities with the way the legacy BIOS and hardware configuration work, even if you have really anything over between 3 and 3.5 gig of RAM, odds are you're not going to be able to use all of it. Nothing's more frustrating than paying for RAM that you can't then use. So that becomes the driving factor. Now, the real reasoning behind that is kind of convoluted, and you had to get into the likes of the Mark Russinovich definition and discussion of, well, how does all of this memory mapping work? But the basics of it are that there are reserved chunks of RAM on an operating system. So if I switch over to my 64-bit laptop, maybe. It was just working. There it is. So if I look at my machine and go into MS Info 32, it will tell me that I have 4 gig of RAM. But even on my machine, which is running a 64-bit OS, there's only 3.93 gig available. So there's about 70K that have disappeared. Not a big deal overall. When you switch over to a 32-bit OS, that 2.9 or 3.93 number is probably going to go down to about 3.3, 3.4 gig. And if you were then to drill into the actual memory maps, you would see that there are chunks of RAM that are just eaten up by the hardware. So on very well-tuned hardware from major manufacturers running a 32-bit OS, usually it's in the 500 meg range. For less expensive hardware or hardware with very large RAM video cards, you could see that number instead of being something like you see on my machine at 3.93, you could see it drop to even below 3 gig. The example that Mark gives on his blog is you buy a machine, you put two 1 gig video cards in it with 4 gig of RAM and an x86 OS. What are you going to see? You're going to see a machine with less than 2 gig of RAM accessible. The video cards chew up 2 gig of it. The BIOS and other things take up a little extra chunk, and you're left with half of the RAM that you paid for. Go to a 64-bit OS, all of it shows up again. So the main thing that you'll want to try to do is anytime you're looking at a machine with more than 3 gig of RAM, you're going to want to run a 64-bit OS on it. Now, as long as you're buying the majority of your machines with less than that, then all right, this probably isn't that compelling of a reason in itself to go to a 64-bit OS. So let's talk about EFI then. How many of you know what EFI is? Wow, that's something that will change over the next couple of years. It hasn't been a big deal so far, but the legacy BIOS that we've been running for a long time has a whole bunch of legacy limitations, one of which being that it is 16-bit code, it can only access a megabyte of memory, and it uses an MBR disk format scheme. Well, when you get into the meat of it, it really doesn't matter so much that it's 16-bit code or a megabyte address space. That just means that it's harder for manufacturers to actually create the initialization ROMs for the various devices in your machine. So they would like to get away from that. But what does it really mean for you? Why would you want to move? Well, we'll talk more about the disk size limitations on MBR in a sec. First of all, let's talk about the machines shipping today that actually support EFI. There are quite a few of them. Actually, I've got a list up here, which we can look through real quick. And I suspect that a number of you, if I look at the right one, already have machines that support EFI. Like Dell supports it on all of their recent PowerEdge servers. HP supports it on most of their corporate laptops. IBM supports it on their servers. Intel supports it on motherboards. MSI, Panasonic all support it in their machines as well. Dell's laptops, all of the 6410, 6510 models all support EFI as well. So can you even tell the difference? Probably not. Why can't you tell the difference? They run in emulation mode. So even though you're running an EFI machine that has this newfangled BIOS replacement that takes care of some of the pains of the past BIOS structures, it runs with an emulation module that enables older operating systems, like Windows, to see what looks like a standard legacy BIOS. So that's the good thing. That legacy fallback really saves the day, so that even though these machines are running a brand new replacement for the BIOS, you can't tell the difference. In order for you to enable a machine to run in that EFI native mode, you would need to go into the BIOS configuration, flip the switch to say, I no longer want to do legacy fallback, and at that point, you're running a pure EFI machine. So, okay, well, why do you want to run a pure EFI machine? How many of you have seen that there are now 3 terabyte disk drives out on the market? How many of you have ever tried to install one of those inside of a PC? They don't sell internal models of those. They only sell them external. Well, why do they only sell them external? Because they won't work as a boot device. If you put a 3 terabyte drive, or really anything over about 2.2 terabytes, into a PC and try to boot it up into any current operating system, except for Windows 7 x64 with an EFI BIOS, it just will not boot from that. It can only see the beginnings of the disk, and you get really odd behaviors. In some cases, you might see 2.2 terabytes. In some cases, you might see less than 1 terabyte. Regardless, you're going to scratch your heads and say, well, this disk just isn't working right. I'm going to send it back to the manufacturer. The manufacturers know this. They know that people won't read the documentation that comes with it that says this won't work as a boot device on a machine with an MBR with a legacy BIOS. So what's the easy solution? We just won't sell one for internal usage. We'll only sell them for external drives. They work great as data drives. You can have as big of a data drive as you want on any version of the OS that's been around for years. But for a boot device, you have to move to EFI. So today I'd be willing to bet that you're not buying machines with terabyte disk drives in them for your general population, but as time goes by, you are going to have machines that have this requirement. And when you want to get to that size and you want to actually boot from one of those devices, then you'll need to move to EFI. There are some additional benefits out of that, well, apart from being able to support a 16.8 million terabyte disk drive attached to this thing. There are some things that Windows can do better on an EFI machine. The most noticeable ones are faster initial booting and faster resume from Hibernate. In both of those cases today, Windows has to fall back on the legacy BIOS int13 calls in order to read data from the disk. That basically means every time it asks for a block of data from the disk, it has to go through multiple layers of thunking software to get down to that legacy 16-bit garbage in order to ask for a block of data. Once you move to EFI, everything moves to native 64-bit, native support for the underlying hardware. It's much faster to read that data from the disk using those native 64-bit calls. So the machine boots faster, it resumes from Hibernate faster, and there is one other additional Windows feature that you would see on an EFI machine, and that's multicast PXE booting. For those of you who have tried to deploy, say, 1,000 machines at a time using Config Manager, using WDS, whatever you're using, you can have it support multicast to deploy the operating system to the machines. That's great, but it just moves the bottleneck. You then realize that I had to now send 120 meg or so Windows PE boot image to those 1,000 machines. And if I'm running a legacy BIOS, that can't be multicasted. There's no multicast support in the BIOS in order to receive that. With EFI, you can actually multicast a small little EFI boot program down to the client, or transfer that just using the normal boot P, and then it can leverage the EFI networking capabilities, which don't require drivers, to then go back to the server and request the actual boot image using multicast. So you can get more scalable deployments in that situation as well. So at this point, those are really the main areas that Windows can leverage EFI. If you are looking for a machine that boots faster, resumes faster, initializes faster, odds are they're going to be using EFI behind the scenes. You'll see the occasional article from a Taiwanese PC maker who said, we've got this new model of laptop. This new model of laptop will go from the time you hit the power button until the time you can log on to Windows in 2 seconds. On a normal machine with a normal BIOS, you cannot post in 2 seconds. On an EFI machine, you can. So you'll see that start to be a compelling feature of, especially on the consumer side, where booting faster, resuming faster, supporting larger hard disks, supporting larger amounts of memory are going to be the driving forces behind that. So just like consumers are kind of leading the way today on their adoption of Windows 7 x64, they will probably lead the way on EFI boot as well. It's pretty simple why. From an OEM's perspective, they're not going to sell you a machine that can't use everything that's in it. If they tried to sell you a 4 gig machine and you looked into MS Info 32 yourself or an Explorer or wherever and you saw that your machine only had 3 gig usable, you would pick up the phone and call them and complain. So anytime, like if you went to the HP website, put in a configuration and ask for 4 gig of RAM, they won't let you choose an x86 OS. You are forced to x64. Eventually, we don't even expect them to offer an x86 version of Windows to the retail market, because it's just another image they had to support. They know they'll ship x64 to support the larger memory machines and eventually to support the larger hard disk models. But once they can get the majority of the machines over to x64, they really want to stop supporting x86 altogether. So I would expect probably within the next year or so to start seeing this particular combination: Windows 7 x64, UEFI BIOSes, and GPT disks. I didn't mention GPT before, but GPT is basically the replacement for MBR. It's been around on the Itanium side for quite a while. It's been around on Windows since Windows 2003, even on an x86 OS, but it was only used for data volumes. Now with Windows 7, you can actually boot from it as well. So that's kind of the whys. The whys are pretty simple: to support more RAM and to support more disk. So then the question is, well, why not? What are the concerns that you would have moving to Windows 7 x64? First off, hardware compatibility, then software compatibility, then we'll talk about drivers some. But the main thing in a lot of cases is just pure inertia. You've always deployed x86 version of the operating system. Well, why would I not deploy the next one as x86 as well? So it kind of becomes just a comfort factor thing, that if you're not familiar with x64, then you're probably not going to deploy it. It sounds like from the number of you that are already running x64 on your own machines, you've gotten past that familiarity standpoint. Now you can at least focus on, well, what about the masses? So the obvious hardware compatibility issue is the hardware has to support x64. Fortunately, since 2006, when AMD originally released 64-bit support in processors, most machines, most major OEMs have at least provided their standard enterprise configurations with an x64 capable processor. Unfortunately, at the same time, they've still sold cheaper machines with cheaper processors that don't support x64. So generally, if you've got the choice, it's not going to be that much additional expense to get an x64 capable processor, even if you're planning to deploy an x86 OS. It gives you that much more flexibility. Go ahead and buy the more capable processor. The exception to that until recently was the Atoms. Any netbook powered by an Atom processor released with the initial wave of Atoms didn't actually support x64. They were x86 only processors. That actually changed last month, I believe, with the release of the new Pineview model of processors, so that they now support x64, and they also support virtualization. So you can have a netbook running Windows 7 x64 and a hardware-assisted virtualization virtual PC environment. There's kind of another group of machines that's kind of in between. These ultra-low voltage processors are used on ultra-portable PCs. So they're kind of in that in-between state. They're not so slow as netbooks. They're not as powerful as your standard laptops. They sit in the middle. They get the battery life of a netbook, but they have the processing power of a low-end laptop. Those are kind of hit and miss. You would have to look at each one of them to figure out which ones support x64, which ones don't. It's not consistent on the processors for those. On the software side, the biggest thing that you'll run into right away is that Windows 7 x64 doesn't support 16-bit software, period. The whole 16-bit subsystem is gone. So if you have any old legacy 16-bit applications, you're going to need to find a different way to run them. You can run them via remote desktop services, virtual PC, virtual machines of any kind. Basically, they can't run within Windows 7 x64 itself, so you have to find some other way. You can leverage the AppCompat toolkit to at least identify the 16-bit applications that are running in your environment. It will flag them and tell you right away these aren't compatible with an x64 OS. A few years ago, the existence of so many 16-bit applications would have really caused issues in this case, but fortunately, as time has gone by it's not as big of a concern. I'm sure if you look through your application inventory, you're still going to find 16-bit applications, and you're probably looking for a reason to get rid of them. Well, here's your reason. Once you move to 64-bit OS, they're gone. On the opposite end, you'll need to deal with especially your antivirus software, firewall software, VPN software. Those will all need to have 64-bit versions. Now, probably a year ago when Windows 7 first shipped, that would have been a major blocker. But over time, the vendors have come around, primarily because of the consumer push, to get all 64-bit versions of those. Let's take a look at the Compatibility Center, which shows you that type of information. So if you go to Microsoft.com/Windows/compatibility/Windows-7, you'll get to the Compatibility Center. And then you could search for something like Cisco VPN. And this was kind of the situation initially. If you were running a Cisco VPN client, version 5 was the latest at the time Windows 7 shipped. It says it's not compatible with x64. If you drill in, you'll see that the vendor states that it's not compatible, 64-bit perspective, but is fully compatible on the 32-bit side. Now, that's one of the actual limitations in this, is that you would look at that and say, well, I'm blocked if I'm presently running the Cisco VPN client software. What this can't tell you is that, well, that was superseded by Cisco AnyConnect VPN client. So this is the 64-bit version that you would need to use. So there may be some infrastructure upgrades that need to go along with the client upgrades. There will definitely be some additional testing that you would need to go through for the 64-bit versions of these pieces of software, but the Compatibility Center at least can give you a good first start on being able to see what the vendors say their compatibility is. Now, from an application perspective, in general, 32-bit applications run just fine on 64-bit Windows 7, but there are some things that you need to take into account. These 32-bit applications run kind of in their own subsystem, and they get a different view of the Windows world. So instead of seeing C program files, they'll see C program files x86. Instead of seeing C Windows System 32, they'll see C Windows syswow 64. So they kind of run into some issues where you may need to apply some shims to get them to find the things that they're looking for in the correct locations. It's almost easier to show it than to describe it. So behind the scenes, these Windows applications are subject to registry and file system redirection. When we look at it from a registry perspective, when a 32-bit application runs, it will see, instead of HKey local machine software, it will see HKey local machine WOW 6432 node. That then has the 32-bit pieces of information in them. So if this application would go looking for, say, something under ODBC, they're not going to find it in the 64-bit registry. They're going to find it in a 32-bit registry key. So if those aren't in sync, or if there are different drivers between 32 and 64 bits, you're going to run into issues like that. They also see a different mapping of the file system. So if we look under Windows current version, they will see for program files, C program files x86, program files x86, C program files x86. Everything gets redirected. Now, if they really want to know where's the real program files folder, they can see it, but it requires looking at a different environment variable. In this case, program W32 or 6432. Same thing with common files and a variety of other paths like that. From a file system perspective, if I go to System 32 and type set just to look at the environment variables here. I kind of see the same picture. Program files, C program files x86, C program files x86. Okay, so I can tell just from looking at that I am in a 64-bit process. So let me start a 32-bit process just by running C Windows syswow64 cmd.exe. Do the same thing again. Now, it's telling me that program files points to C program files x86, program files x86 points to the same place. So, why does that even matter? Well, let's take a look at another example. That there could be some components on a Windows operating system that exist in only one or the other environment. They could be 32-bit only, they could be 64-bit only. So even from an administrative perspective, you might need to worry about, well, is the PowerShell snap-in that I'm using a 64-bit snap-in? Is the COM object that I'm using in my login script a 64-bit or a 32-bit COM object? So if we looked at PowerShell, if I run PowerShell.exe, now again I'm in a 32-bit command prompt at this point. I can ask for the registered snap-ins, and PowerShell will tell me that there are 2 of them. So now let me run the 64-bit PowerShell and run the same command. Now there are 3. What's the difference? Well, PowerShell snap-ins can be registered as 32-bit snap-ins, 64-bit snap-ins, or both. So you have to be able to potentially look through your logon scripts, look over your administrative utilities, figure out, am I using the right platform version of each piece as I'm going along? Let me go back into the 32-bit command shell just to show one other thing. If I look at notepad.exe in System32, I see that. If I look at the sysnative folder, though, which is another one of these file system redirection items, sysnative actually points to the real System32, where System32 is pointing to syswow64. So I get different answers. Why do I get different answers? Well, one's a 32-bit version of Notepad, the other one's a 64-bit version of Notepad. So that sounds simple enough. Anytime I want to get to the right version of the 64-bit version of an executable, I can just reference sysnative. Well, that's only partially true. That only works from a 32-bit process. If I tried to do that from back in my 64-bit process, if I could type, system cannot find the file specified. So sysnative is a redirected alias that only exists inside of a 32-bit process. It doesn't exist inside of a 64-bit process. So you kind of get into these interesting behavioral issues, and when you're writing applications, you kind of need to have an understanding of what's in a 32-bit registry hive versus a 64-bit registry hive. What can I find on a 32-bit file system view versus a 64-bit file system view? So those are the types of application compatibility issues that you'll need to test against. For an application that knows what it's doing, it can actually request that those redirections be turned off. So that's the default behavior in Windows. If the application is smart enough to know that I'm a 32-bit app running on a 64-bit OS, I need to look in the appropriate places, it can say, please don't virtualize the registry and file system for me, give me the native picture. But in that case, they had to realize that if they load a DLL, by default, they're going to get a 64-bit version of it, which isn't going to work in a 32-bit process. Just a little gotchas like that. How many of you are using a configuration manager to do any type of deployment? App installs, OS deployment. To get matters, to make them a little more complicated, configuration manager running on a 64-bit client on a 64-bit OS runs a 32-bit config manager client. So let's say you run a task sequence on a 64-bit OS running a x86 config manager client, and you go to run a VB script as part of that task sequence. Is that going to be a 64-bit task sequence or 64-bit script, or is that going to be a 32-bit script? It's going to be 32-bit by default. If that script has to call an operating system executable, what's the script going to get? Well, if the script's running x86, the executable is going to probably run x86. So you end up getting into some situations where you had to have scripts that do some rather interesting things, like we do in MDT. We had to do some weird things like this. If the file exists in system root system 32 called server manager CMD, that's the one we want to use. Otherwise, if it exists in sysnative, that's what we want to use. Otherwise, I give up. Just use the file name and hope it's in the path somewhere. So you get logic like that to try to deal with the situation where, will this script run as an x64 script, which it would in MDT Light Touch? Will it run as an x86 script, which it will in Config Manager? So we have logic in there like that. So you think, well, there's this nice checkbox in Config Manager where you can say, please disable file system redirection. Okay, that will then cause my script to run as an x64 script. Great, except my script requires access to a Config Manager COM control. That Config Manager COM control is x86 only. An x64 process can't load an x86 COM control, so the script fails. You just had to throw your hands up in the air sometimes and say, what the heck were they thinking? But fortunately, as we move forward into Config Manager vNext, they'll start shipping a 64-bit Config Manager client, so some of these issues will go away along the same time. If you're running any applications that require drivers, which is especially true for any type of hardware dongle that you use for licensing purposes, you will need a 64-bit version of those drivers. You can't run an x86 driver on an x64 OS for any reason. You can try, but it'll blue screen. So you have to figure out which of your applications actually contain drivers, and then try to adjust or to find new versions of those applications that are 64-bit compatible. So let's shift then to talking about Office 2010. Prior to Office 2010, you didn't have a choice. There was a 32-bit version of Office, and that was it. When Office 2010 shipped, guess what? There's now a 64-bit version of Office, and with that, you can do silly things like open an Excel spreadsheet that's larger than 2 gig. How many of you have ever tried to open a 2 gig spreadsheet? My God, what kind of spreadsheet is that? You can also get larger Microsoft project files. Basically, you can have more memory at your disposal, and the applications can then take advantage of it. I don't see that as a tremendously compelling case for 64-bit at this point, especially when you take into account the compatibility concerns. I'm sure all of you are running multiple Office add-ins. Every one of those Office add-ins has to be 64-bit if you're going to run a 64-bit version of Office. How many of you have ever seen a 64-bit Office add-in? Other than a few from Microsoft and a few that actually ship with Office 2010, they don't exist yet. There are also challenges around macro code that talks to the Windows APIs. So if you've got some fancy VBA code in your spreadsheet that uses a declare statement to say, I want to call this Windows API, to pop up a dialog, or who knows for what purpose you might want to do that, those will have issues on the 64-bit OS because they may need adjustments for the 64-bit APIs. So the general recommendation is don't move to Office 2010 x64 until all the add-ins in your environment are 64-bit, or that there are 64-bit versions available. When will that happen? It's going to be a while. So probably 2, 3, 4 years from now we can revisit this. But for right now, we would just say always run the x86 version of Office 2010. Except on the few machines where you might actually want to open up a 2 gigabyte Excel spreadsheet and process it in RAM. But I suspect there might be 1 or 2 machines in your entire organization where you would ever want to do such a thing. So keep it simple. Run the 32-bit version of Office. It runs quite well on top of a 64-bit OS. Next item on the list, Internet Explorer. Guess what? On a 64-bit OS, there are 2 versions of Internet Explorer, a 64-bit version and a 32-bit version. 64-bit's always better, right? So always run the 64-bit version. Now we just went through that with Office. Run the 32-bit version of Office. Same recommendation here. Run the 32-bit version of IE. If you run the 64-bit version, which is available and on the Start menu, it can't load any 32-bit ActiveX controls. It can't run any 32-bit add-ins. It requires all 64-bit to do its thing. Some things like Adobe Flash aren't available for 64-bit IE. In the case of Java, there is actually a 64-bit version of Java that you can download from Sun and install. That would be an additional install, because you would still need to install the 32-bit version of Java in order to support the 32-bit browser. So in that case, you'll be running 2 different versions of Java at the same time, one to support each browser. So pretty simple. Run the 32-bit version of IE. Don't try to run the 64-bit version. Just to give you an idea of what that would typically look like, it is actually good for a few things because there's no Flash. So if you want to see what a website looks like without Flash, you can do that. Like in this case, if you go to YouTube, on a 64-bit OS with a 32-bit browser, you get the standard controls in there. If you try to do the same thing on a 64-bit browser, you just get a big hole where Flash would have been. There's nothing there. One other thing worth pointing out is if you look in the Task Manager at the processes that are running, you can actually see which ones are 32-bit just by the star 32 at the end of the number. In the case of 64-bit, they aren't tagged. So fairly easy to tell apart which ones are the 64-bit, which ones are the 32-bit. So what about drivers? In the past, when Windows XP x64 came out, unless you installed one of the 3 or 4 different PCs that actually had drivers available, yeah, you were out of luck. You couldn't run the 64-bit version on much of anything. With Windows Vista, they actually changed the logo requirements to say that when you submit a driver for certification, you must submit both 64-bit and 32-bit versions of that driver, even if you only intend to run it on an x86 OS. Now with Windows 7, they've actually modified that a little bit. Now you can submit a 64-bit only driver and not submit an x86 one at all. So vendors can start making the choice to say we're only going to support 64-bit going forward. Now the market kind of rules there, so as long as there is still a large percentage of x86 OSs running out there, they're still going to produce both x64 and x86. But as you start looking at drivers for more specialized hardware, higher end scanners, printers, those types of things, you may start to see cases where there is only a 64-bit driver. So you'll definitely have to have both sets of drivers. Well, you'll have to have a 64-bit set of drivers in order to deploy the 64-bit OS. You would need an x86 set of drivers to deploy an x86 OS. So we'll talk about the implications of that in a little bit, but the basic idea here is that availability of these drivers shouldn't be a big challenge for things that you're buying new. If you buy it new, it's got a Windows logo on it, it's probably fine. The bigger problem is the older stuff. How many of you still have 10-year-old laser printers floating around your environment? Guess what? They're probably going to no longer work. That's probably a good thing in this day of green IT, because those things were power hogs, so it's probably time to throw them away. But that's basically the only answer for those. If it's an older device that doesn't have a 64-bit driver, you're out of luck. You're going to have to just discard the device, buy a new one, and move on from there. So that's probably your biggest roadblock. How many of those devices do you have in your environment? How many of them do you actually still need to support? Can you afford to replace them? So let's look at, wow, that slide turned out interesting, but let's look at the view of Gartner. So the text that you can't read underneath that is that these 2 bullet points are from a Gartner white paper that was released in October 2009 by one of their analysts. They have basically stated that corporate buyers need to establish a position on moving to 64-bit as part of their Windows 7 planning. That's kind of the wishy-washy way of saying you should at least think about it. We're not quite telling you you must do it, but we expect 75% of enterprises to do it by 2014. So that kind of gives you an idea of what they think is happening in the market. They see the majority of people in the next 3 to 4 years will be moving over to Windows 7 x64. So really it's only a matter of time. The question isn't will you or when will you go to, well, the question is when will you go to Windows 7 x64? It will happen eventually. Still, we don't know what platforms will even be supported with the next version of Windows. It might be that Windows 7 is the last x86 version of Windows. Who knows? But as we move forward, more people will make that choice and they'll move to 64-bit on their own. So then we had to talk about, well, what if I can't move 100% of my environment? What if I have to split it up? Some machines running an x86 OS, some running an x64 OS. Should I do it? Maybe. In your environment, you have to recognize that that will require additional work, primarily because you need to then have multiple images and multiple driver sets, and you have to do additional application testing. You need to test your applications on both the x86 OS and on the x64 OS. If you can get it so that you're predominantly one versus the other, then that's probably worth doing. If it's something where you would expect your environment to be 50-50, maybe it's too early for you to move to 64-bit at that point. If 90% of the environment can be running x64 and 10% can be running x86, great, because the burden of supporting both won't be that bad. Same if you flipped it around. If 10% are x64 and 90% are x86, your support load's not going to be that bad either. So then the question is, well, can you actually be pure? So can you run only Windows 7 x64 in your environment? Yes, but it's going to be easiest when you're doing that as part of your hardware refresh cycle. So as you're bringing in the new hardware, getting rid of the printers that don't work, adding 64-bit processors, it's going to get easier as part of that, that deployment cycle. So then we had to talk about the tools that actually are used to do the deployment. Do they actually support Windows 7 x64 deployments? Fortunately, the answer is yes, and they've been doing it for a long time. So even back in the Windows XP x64 days, all of these tools supported x64 deployment. Windows Deployment Services, not only does it support deployment of 64-bit Windows 7, it also supports multicast PXE boot, which we already talked about. That also means that in order to do that, it has to support UEFI, because that is a function of the UEFI capabilities. Unfortunately, that's kind of where the support breaks down for UEFI. It's not yet fully there in the Microsoft Deployment Toolkit. It's also not presently completely there in System Center Configuration Manager 2007. They both support deploying the 64-bit OS, but using a legacy BIOS and an MBR disk. In MDT 2010 Update 1, we did add some experimental support for UEFI. We can actually do a bare metal deployment to an EFI machine, but we haven't tested that with very much hardware to prove that it'll work in the general population. It works fine with the one UEFI machine that we had available at the time to test it on, which was a pre-production Dell Latitude E6410. But beyond that, we don't know. So as we move forward with the successive updates to MDT, we'll go through the testing cycles to prove that does it work with the typical server EFI hardware, laptop EFI hardware, desktop EFI hardware. Configuration Manager 2007 really doesn't support EFI today. There are some scripted workarounds that you can add into the task sequence to make that work. It's just kind of on that borderline of something that's not truly supported by Config Manager. Hopefully that's something that'll change with the next version, but at this point they're not committed to that either. So a variety of links you can get from the slide and read up on them in a little more detail. We already looked at the Compatibility Center. It's great for seeing that at-a-glance view of which applications are compatible with x86, which are compatible with x64. The AppCompat Toolkit ties into that same back-end database, so if you use that to inventory your environment, with the 5.6 release of the AppCompat Toolkit, it adds support for scanning for 64-bit applications and pulling down that 64-bit compatibility data. I posted a link to Mark's blog posting that talks about the physical memory limits in Windows and why you can't access all the memory that's present on the machines. Posted a link to the various blog postings that have been made by the Windows team, discussion from the UEFI forum on why you run into a 2.2 gigabyte limitation, or sorry, terabyte limitation on MBR disks. A general white paper from Microsoft that talks about why Windows plus UEFI and what are the additional capabilities that you get with that. And then just a general discussion from Intel saying, well, why should you make the move over to EFI as well? So that's pretty much it. How much time did that take? So we've got a few minutes for questions. I don't know that there are any mics around, so if there are any questions, just shout them out and we'll see if we can repeat them. So the question was shell extensions on Explorer. So if we go into here and look at explorer.exe, we can see that it's running as a 64-bit process. So if you had any COM-based shell extensions, they would need to be 64-bit as well. If they're .NET-based shell extensions, then they could actually support both. So you will run into some AppCompat issues around shell extensions. If you have an old printer, can you install a driver into XP mode? You can, but it would require that the device be a USB printer. I haven't tried that with a serial or a parallel device. It might work, it just depends on the timing issues around that particular one. But with USB redirection, if it's a USB type device, you could redirect that into the XP mode, install the driver in there and print from within XP mode. But there would be enough limitations in that I wouldn't say that's a general purpose solution. It just might mean that one app that you're running in XP mode, you can actually print from it. XP mode is kind of one of those interesting technologies that everyone says, well, XP mode is the solution to everything. It's kind of that fallback that if there's something that just doesn't work, yeah, you can run it in XP mode, but XP mode is basically a sandbox. You get an XP OS with full admin rights and you can do whatever you want to it. MedV is kind of the managed equivalent of that. So give me a managed environment where I can create my own corporate VHDs, push those out to the machines, and really control those using the MedV policies. We are working on a third solution, the P2V migration for software assurance that I showed in an earlier session this morning, which really is to take an existing XP OS and just do a P2V conversion into a virtual PC VM as kind of the third option there. All of them are bad, basically. All of them will result in an increase in the number of PCs in your environment that you need to support. But when you have those critical applications that you have to get working, it might be the only choice for you. So the question was, with an EFI BIOS, can you have a dual boot option with 32-bit and 64-bit? Well, not really. You could have dual boot. Basically, EFI provides kind of a boot menu type capability where you can go in and define multiple boot options. Basically, the BCD configuration that you see inside of Windows 7 very closely mimics the structures of EFI and really was designed to support that migration to EFI. But just because there was no demand for an x86 version of an OS that would run on an EFI machine, Microsoft doesn't support running Windows 7 x86 on an EFI machine. You would have to use the legacy fallback capability. So what I'm not sure about, because I've never tried it, is can you have EFI running in native mode, but then have a boot option that says run this with the compatibility layer? I suspect that's possible, but it's not something I've ever attempted. Personally, dual boot machines are trouble for a variety of reasons, and yeah, generally virtual machines are so much easier, so I usually go that route. So the question was, can Windows 7 x64 run on a Intel-based Mac? Through Boot Camp. It can, yes, but you would be running in BIOS emulation mode. Basically, Boot Camp provides its own BIOS emulation. The version of EFI that Apple supports on their hardware is older. It's like a 1.x version of EFI, where Windows requires 2.x. So you can't natively boot a Mac using EFI into Windows 7, but Boot Camp provides that legacy BIOS that would work fine. Sure.
32-bit Windows 7, moving to 64-bit, is there an upgrade path or is that a wipe and install?
So the question was, if you are running Windows 7 x86 and you wanted to go to Windows 7 x64, is there an upgrade path or do you have to do a wipe and load? Yeah, it's a wipe and load. There's no cross-platform upgrades of any kind, which kind of makes sense. It's pretty much a complete replacement of every file in the OS anyway, so yeah, you'd have to just migrate the data, migrate the apps, and do a clean install. Okay, any other questions? If not, I think we're about out of time anyway. So thanks for listening, and hopefully that was somewhat useful. If you've got any specific comments or concerns or suggestions for what I should cover in addition to this the next time I do this, send me an email. My email address is mniehaus, M-N-I-E-H-A-U-S, @Microsoft.com. You can get the last name off of the first slide, and I'll get back to you on those. So thanks.